Is it okay? Hello? Yeah, I think we're going to start a bit late today. If everyone is settled, I think we can, well, start, I guess. Today's BOF is mainly about RIPEstat. We try to combine the live demo with some kind of presentation about RIPEstat. So, my name is Teuschel. I am a software engineer at the RIPE-NCC, mainly working on RIPEstat. And today's structure for the presentation will contain 4 parts. The first part will be some kind of kickstart into RIPEstat. So we give an overview of all the views we have, how we're going to use RIPEstat, and just to give you an idea in which cases RIPEstat can be useful for you. The second part are use cases. I tried to keep this part quite short because the main idea about the presentation is also to get use cases from you guys, so from our users. And I just picked 2 use cases which we will present later on. The third part will be some kind of outlook on the planned features. So what we are working on right now. And this should also give some food for thought to start some kind of discussion about RIPEstat. And the last part will be some kind of questions and feedback section. Just to make this clear, I mean, basically we encourage to have questions during the presentation, but we also stream this presentation over WebEx, and for our attendees over WebEx, we would like to have the questions put more or less in the last section. During the presentation, we would like to have the WebEx users use the chat function on WebEx, so that we can accumulate some questions and then reply them in the last section. Okay. First of all, short recap about RIPEstat. So the basic idea about why we created RIPEstat was that we all know that we have a lot of internet-related data out there. The only problem with this data is that the information is quite scattered. So you have to use a lot of tools, you have to visit a lot of places to get the information you want. So the basic idea about RIPEstat is to combine all the different data sources under one interface and make it easier for you to get the information you need. And when we are talking about data sources, then I think we mean that we support our own data, RIPE-NCC data, for example, routing information, active measurements, or the registration data, as well as external data. We will see some examples of external data later on when we go through all the views. And before we're going to start with the individual plugins which we present, I like to have a look on some basic features of the application. So we try to group the information in this kind of boxes. We're going to call them view. This is just per definition. So in these boxes we're going to present a view on a specific data set. And this should also be, you should be able to interact with the data over the views. Another important feature of the application is the methodology. The methodology should provide you with all the information about what data source is going to display in the view, how we process the data, and how we display the data. So whenever you have detailed information or you feel a bit uncertain about what data we're going to present, the methodology will be your friend. Another common feature among all of the views is the raw data. I'm gonna go into more details later on in the planned features about raw data, because right now the idea of the raw data API is not that so roughly implemented, but that's something I'm gonna talk about later. So before we start with the first view, I would like to explain some kind of methodology I used creating the slides. So in the lower left corner, you see two checkboxes. Basically, with RIPEstat, we support two resources. One resource is an AS, and the other resource is a prefix. So as we go along through all the plugins, we will present these two checkboxes, and if you see a tick, for example, at a prefix or at AS, that tells you if the view supports these resources. So in this case, first of all, we go through some views that will be supported by an S as well as a prefix. Okay, resource information. The idea behind the resource information was to create some kind of view that gives you some general information about the resource. At the current state, we're gonna present if the prefix or the S is announced on the internet. Basically, this view is based on our routing information. The routing information is collected by our RRCs, the remote routing collectors. We have 15 of them, so this is our network to collect the routing information. And for ASs and for prefixes, it gives you an idea if the resource is seen by one of our peers at the location of the RRCs. Additionally, for prefixes, we're gonna provide you with some alternatives in case we can't find the queried prefix. So either less specific or more specific prefixes will be presented. Okay, the next prefix, or the next view, that's gonna be also for prefix as well as AS is the whois information. I think we don't really need to go into details about the whois service, but there's one thing with this view. We still have to work a bit on the smartness of what data we're gonna present and which data we might leave out from the view. But that's also something which I want to talk about later on when we come to the planned features. So that brings me to the next view, which is the geolocation. And as the name implies, it gives you some information about the usage of a prefix based on a geographical information. So we provide the information for an ES, which will be thought as the collection of all the announced prefixes, as well as for individual prefixes. The main difference between the two views, between the information about an AS and a prefix, is that the aggregation level. For an ES, we have quite a lot of information. So to cut down the amount of information, we aggregate on a country level. So for example, if you're trying to search for any ES, then we will give you the information in which country the AS is in a way used. I mean, AK, it's prefixes. And for prefix, we go one level deeper, and the aggregation level will be on a city level. So if you query for a prefix, you will get detailed information in which city it is actually used. And this is the information that's displayed on the maps. And additionally to the information on the maps, we try to provide you with more detailed information. And that's going to be presented in a table below the map. So if you click the link below the map, you will get a tabular view of all the information we collected about that. So the basic idea is that you use the view and you can be able to dig into the data on more details. All right, then the next view is the visibility. Visibility is based on routing information, and the basic idea about that is we're going to take a resource and we see how it is seen by our remote routing collectors. So with the 15 locations, it could be that in some locations you're visible for all our peers, for all the AESs we are peering with. That means a visibility of 100%. If the visibility is going down below 100%, that means that one of our peers can't see the resource you're querying for. So either a prefix or an ES. And as well with the overall idea about getting more detailed information into the view, we're going to present you, in case there is some kind of problem with the visibility, with the detailed information about the ESs that can't see the specific prefix. Well, the next view is the allocation history. Allocation history is based on registration data. Registration data on two levels. First of all, we have the IANA level, and the second one is the RAR level. And we're going to present the information also for both of them, for an ES and for a prefix. So the next views I'm going to present are specifically for a prefix. So the ES routing history is also based on routing information. And as the name implies, we're going to show which AS originated the specific prefix we're querying for. Another view that is only available for prefix is the address space usage. The address space usage is also based on registration information in a way that we're going to tell you about assignments and allocations that are related to the prefix you're looking for. We have altogether 3 ways to display the information. The first one you're going to see behind me, it's the pie chart, which could give you the information about how much of the entire address space covered by the prefix you're looking for is, for example, assigned, maybe PI or PA. And we also present the information in a tabular view. And the next step above that are the allocations. So as we can see in the slides, we're going to present the information about the allocation in this view too. Okay, the next view. I mean, there are quite many views. That's yeah. I mean, so far it could be a bit boring, but hold on, we have to go through, and I think we still only have about eight views left, and then we can go to the more interesting parts. So the BGP looking glass. The BGP looking glass is based on routing information. Additional to this, we're gonna present real-time routing information, because whenever you request the information for a prefix within this view, we're gonna connect to one of our RRCs, which is running a Quagga client, and get the information for the routing state for this prefix. So in a way, it's a view like the router would see it. And as I said, it's real time, so it could be really helpful in many situations. The next view is about blacklist data. So far, we utilize 4 different blacklist data sources, namely the Spamhaus Drop database and UTC Protect 1, 2, and 3. This view is also split in 2 sections. You have a graph which gives you information about the blacklist entries over time, And below the graph, you're going to see a table with the detailed information about each of the entries. Then the next view is BGP updates. This is basically a kind of graph that shows you the activity, so namely updates of withdrawals of the prefix you're querying for. So, I mean, I think that doesn't really need much more explanation. The next view is about related prefixes. With this view, we try to combine prefixes that are related to the prefix you're querying for. This data is based on routing information, and for example, it could give you information about overlapping prefixes, could be less specific or more specific, and also adjacent prefixes, left and right. The next view is the routing consistency. Routing consistency combines two data sources. First of all, registration data with the WHOIS service. The other one is routing information. And we try to look on in both data sources and find if there are matching pairs. So if you query for a prefix, we're gonna look the information up in the WHOIS data, and if we found the prefix, then we present, well, found, or if we don't find it, then we present a not found. The same goes true for the routing information. This is the column with the BGP. So these are all the views that are used for prefixes, and that takes us to the views that are only used for ASs. The first one is the announced prefixes. I mean, this is pretty simple. We're going to take all the prefixes that are announced by an AS and just list it with more detailed information. For example, when it was announced first and when it was seen last, in a way. Then the next two views are basically using the same data source, but we try to present the data in a different format. Okay. Number of announced prefixes over time. This is a graph with history that just gives you the total amount of prefixes that were announced or originated by an AS. And we found it quite useful to split the information in IPv4 and IPv6. The next view is about the prefix size distribution. Same data, routing information, and but this time we do some kind of aggregation over the prefix length. So, for example, you can answer questions about 25% of the announced prefixes for this AS are of the size 25, /25. For this specific view, we have chosen to combine IPv4 and IPv6. I mean, we can argue about that, and I think we should. I mean, in a way, this should be all about encouraging some kind of discussion about what is really useful and what might be not that useful, so that we can get an idea about more specific use cases. The next view is about the prefix routing history, and if you remember, we had the AS routing history. AS routing history is the pendant to the prefix routing history. So it will give you some kind of information about which prefixes were announced by this AS over time. And again, this is also based on routing information. The next view, again, is based on routing information, and if we take all our locations of the RRCs, we measure the AS path towards our peers. So, for example, if I pick one of the RRC locations, for example, Vienna, at VIX, I think RRC number 5, then we present some kind of AS path length metrics. Namely, it's the minimum path, the average path, and the average path with no prepending. And well, we just try to display the information for all of the RRC locations. Okay, these are all the views that we're gonna support at the web version. And when I'm talking about a web version, we also created some kind of mobile version. Well, it could be quite handy if you have the information on your iPhone or on your iPad. And I'm specifically mentioning the iPhone or iPad because so far we only support iOS. And if we have enough demand for creating a different application, well, then I think it would be no problem that we create it for maybe Android, well, maybe not BlackBerry, but yeah. And sometimes we also got, in a way, people talking with us about HTML5 version. And the reason why we didn't try to create a HTML5 version is plainly because the performance of HTML5 is too low to actually support all of the views. So sometimes we just had to get the native support from the operating system to create smooth animations and all that. So if you're interested in more information about the mobile version, then I would direct you to ripe.stat.net, stat.ripe.net/mobile. And I think that brings me to the use cases. So we're going to switch to my local machine. Yeah, of course. All right. So the first use case I picked, imaginary, is locating a spammer. So the IP address 140.78.93.50 was the former IP address of my student room in Upper Austria. Not that I ever tried to create any spam, but I think it's a good example to visualize what I'm trying to do with that. Okay. So first of all, we could use the geolocation plugin, and I guess in this case, it's already quite obvious that it's within Austria. But I want to dig a bit deeper, so that's why I'm going to use the prefixes with the detailed information. And if I want, I could use the filter plugin within the table. So if I punch in my IP address, sure, yeah. Then I see it's actually located in Linz. Well, you could see that. And just to get more information about the whole prefix, we could use the Blacklist View. And we're going to see that there are some activities, or there are some blacklist entries. So I'm a bit curious about if it's actually me. That's why I could use the table of the blacklist entries. And here I'm going to enter my IP address. And, well, definitely I see it was not me. I mean, I know some of my friends might be in there, but if I have the IP address, I think it's quite easy to filter the information to the one pieces I really need. And, well, if you want to perform some action against some spammer, I mean, then you still have to use RIPEstat, which I'm not going to show right now because I think that's nothing new. Another use case could be about the visibility. So for this example, I'm gonna use the RIPE-NCC AS, that's the quad 3, and scroll down to the global visibility. And in this case, we see there, it's almost perfect, but we have one problem, and one problem is there. So if I want to get more information, I just click on the map, and then I see that the visibility is as low as 89%. That means there are some problems. And to identify the actual problems, I could use again, from an overview side, we go to a more detailed view via the table display. So in this case, we see that the location that is affected is New York. And one of the peers that actually couldn't see the prefix, or one of the prefixes that were announced by our AS, is the one 6939. So then again, if you want to take some action, you take the information from this side, go to the WHOIS service, and then find technical contact. So these are the two use cases that I tried to present. I mean, you will, you're gonna see that it's not that many use cases. But as I said before, that's one idea about the BOF session and the live demo, to get more information or to come up with more use cases by our users. So I think we can switch to the presentation. All right, that takes us to the third part of the presentation. That's the feature outlook. And one of the first things we developed RIPEstat for a bit more than half a year, and along this development path, we learned quite a lot of things. And one thing was that the rigid structure of how we present the information is very inflexible. So we came up with some kind of different approach to make more use out of the data. And this is about the widgets. A widget is basically the same as a view, but not embedded in the whole framework of RIPEstat. So the widget should be some independent interface which could interact with the underlying data layer. And the good thing about that is that you can actually grab some kind of code, maybe a div element with some JavaScript code, and you can implement it or embed it in any website. So if you want to monitor, add some kind of monitoring about the prefixes of your AS, maybe the visibility, or also maybe blacklist entries, you just grab the predefined scaffolding code, add it to your web page, and you can present this kind of data. And I think the idea behind that contains a lot of potential. So, another thing we also try to offer with this kind of widget thing is a common JavaScript API. So you could be able to actually, copy the same functionality that we have on RIPEstat on any other page with the ability to control all the widgets you included in one web page from a central point. Another thing we thought about just to make the data more useful is the raw data API. I mean, it's already possible to retrieve some raw data, but we want to go one step further. We really want to decouple the presentation and the raw data. And in a way, it's plain and quite simple. You will have some URL-based API where you append some arguments, for example, resource, time frame, and format. I mean, I guess that these will be common over all the views. And the other one might be, for example, for geolocation, the granularity, if it's maybe on country level or city level. So let me give you a small example. So you will have a URL where you append some parameters, and these parameters specify the data which will be covered by the raw data API. And for example, also granularity could be one of these things. Okay. Then the next thing, which is in the planning, is about data quality. I think I don't really need to stress how important data quality, especially for internet data, is, because if the data quality is bad, then something will happen. Something will happen which is maybe not good. So as some kind of trusted source of data, what the RIPE NCC is, I think we should especially focus on data quality. And just to give you some examples about that, some of our views which we saw before, it's the resource information for a prefix, which contains the data for a prefix that is not announced. And we're trying to give you some alternatives. In this case, we're going to present you some less specific alternatives. And you're going to see there's a 128/2. And the problem is, actually, it is seen by one of our peers of these 15 locations all over the world. But it's not widely used. I mean, in the contrary. I mean, I think actually we shouldn't display this information. And these are some things I think we have to work on to just increase the data quality and present really a high standard. As another example, I could give the geolocation database. I mean, right now, geolocation database is an example for an external data source. We are using the MaxMind GeoLite database for that. So actually, we don't really, we don't have any handle to change the data in there. I mean, not now, or not yet. And you see there is one entry which states as the city group. I mean, actually, I'm not native Dutch. I'm living in the Netherlands only for 1 year. So, but I'm pretty sure there is no city with the name group. So these are also some things that should be enhanced should be fixed with higher data quality. Also, an example is the WHOIS information. So, as I said before, I mean, we still have to work a bit on the smartness of the data we are presenting. And if you see in the description line, there's a dummy description, and that's also something that should not be there. So, well, these are the feature outlook, or well, our planned features for the next time. And that takes me to the question and feedback section. So, if you haven't got a question right now, then I would well welcome you to visit us at the info booth that's around the info hub during the RIPE meeting. So, and if you will, well, maybe some questions will pop up really after the RIPE meeting. Then we still have some kind of ways to give feedback. One way is to just send us an email on ripestat@ripe.net. There are the comments on the website. Then there is the RIPE Labs article about the section about RIPEstat, and also the MIT working group mailing list. So, well, that means if you have any questions, you could state them right now.
I don't know if I need to identify myself. I should, yeah. Okay. I'm Sebastian Castro from Resto, the New Zealand Registry Services. I really like your diagrams and visualization. I'm a kind of crazy guy for visualization data. But my question is about the access to the raw data. How frequently or how fresh is this data going to be? So 1 day old, 1 month old, few hours old?
Well, I mean, so far it depends, because right now we still have different data sources with different update factors, I would say. I mean, risk data is pretty recent, so every 8 hours, at least a bit longer, because we need some time for processing. BGP Looking Glass, as I said, is real time. Blacklist data, well, that's not real time, but that's not our fault in a way. Also geolocation, I mean, we're gonna update geolocation every month, but the problem is that the data sources we're using for that are just lacking behind. Then we have to add some time for processing, but that's actually something we're working on. I mean, we're working on a huge cluster system using Hadoop and HBase to speed up the processing to almost real time. I mean, we know that some of the data only makes sense if you have them as soon as possible, yeah?
Yeah, so a suggestion would be if you can document the expected time frame for having the data will manage the expectation from the data consumer perfectly.
Sorry, maybe I haven't mentioned that before. That should be in the methodology. So for each of the views, we have the methodology section, and the methodology section should mention for each of the data sources what is I mean, how current the data is in a way. I mean, it will become much better if we gonna implement the raw data API on a separate level, because right now we have some kind of mixture between presentation and raw data. And if you want, for example, tackle data quality problems, they are obviously on the raw data level. So, but if you have them intertwined in a way, it's much harder to find what is really good data. And I mean, if you want to tackle data quality problems, and I think the same goes through for raw data. So whenever you request the raw data, we will implement some or attach some kind of information how current the data is. So you will see, okay, this data is 8 hours old, something like that.
Okay, so second question. We are users of the DNSMon data. Do you have any plans to include the DNSMon data on this whole thing?
Maybe Daniel could answer that.
Okay. My name is Daniel Kahnberg. I'm actually I'm the chief scientist at the RIPENCC, and I'm responsible for this stuff. What I can say is that as far as DNSMon is concerned, we actually have brought the time lag back from an hour to 5 minutes in the last weeks or so. So you should, if you are a subscriber, you should be able to see that. And we realize that stuff needs to be more real, as much real time as we can make it. And certainly for the data that we measure ourselves, we try our very best to do that. And it's not so easy, because in the case of DNSMon, it's like something like 5-6 dozen different systems all over the world that we have to collect the data from, and then visualize it and all that stuff. But we're working on that. And to integrate DNSMon data into this, we're actually going one step further, and that will also become clear during this meeting. We now have actually extended the Atlas, the thing with the really small probes, to do the same measurements that the DNSMon boxes do right now. And there is definitely a lot of possibility to integrate those measurements into DNSMon and then use DNSMon measurements in all our other products. So our general, what Christian tried to say is what we're working on right now, and it's still a little bit away, is to push all the data that we have into a big database, which we call the INRDB, and then be able to actually make products that take data from all the sources that we have. So to answer your question, yes, the DNSMon data is going to roll into this at some point because it's going to roll into this big repository that we're building.
Okay. Thank you.
Okay. Thanks, Daniel. Any more questions? I mean, if we don't have any more questions, I mean, I would conclude the presentation with just to point to the next public demo, which will be at the end of next month. And I would encourage, well, I would like to welcome you to visit us at the info booth and maybe discuss some kind of use cases. Because one crucial part of the development of RIPEstat is that we want to try involve the community and build the application as the community needs it. So, well, I would really like to see some of you at the info booth and just talk about some use cases, and then then we can create even better applications for you. I mean, basically, this is for you. So, all right, thanks a lot. Yeah, that's something I already forgot. But that's the best part. So wait. At 7, well, maybe a bit later, there will be some welcome drinks in the first floor. So yes, up there.